Here's the second theory video in 4.1. It's radians versus degrees, and this is, I want to make sure that you understand this. And radians and degrees are like feet and meters. They tell you the same angle, but they use different measurements. Are you any taller in feet than in meters? No, your height doesn't change. The number, the measure of it does, but not the actual height. So it's the same thing. And the key idea for radians is going to be that 360 degrees, I'm going to write it out, is equal to 2 pi radians. So 360 equals 2 pi. So I'm going to put quotes around that because we're not saying the numbers are equal at all. Okay. So remember, if we look at a circle is 360 degrees. So that's going to be 360 degrees. If we think about radians, same circle, same angle, just has a different name, 2 pi. Okay. So that's going to be a key idea. Okay. So just some things, one thing I want to remind you of is that the circumference of a circle is equal to 2 pi r. 2 pi radii. Pi is about 3.14. So 2 pi times the radius is equal to about 2 times 3.14, about 6.28 times the length of the radius. Okay. So I'm going to start with the question. We talked earlier about arc length. And if you remember, we had an arc length formula. And that arc length formula was this. Let me kind of remind you. So here's a circle. Here's an arc. The arc could be anywhere. I'll make it go to here. Here's the angle. And again, we're measuring it positive. This is S. So S goes from here over to here. So in other words, if I want to just isolate things, I draw my angle, and this would be S. And we saw that theta in degrees times pi times r divided by 180 was equal to S. Now, if I know what S is, I could figure out, if I know what S in the radius is, I could figure out what theta is. Okay. Okay. Oops. Okay. So what I want to do, here's my question. If S is equal to 1 radius, what is the angle? So in other words, I'm going to say if S is equal to R, which is a better way to say that, what is theta? So this is what I'm going to do. So here's my formula. I'm just going to plug things in. My S is R. So notice I have R's on both sides, so I can divide both sides by R, and I'm left with, so if I divide everything by R, those cancel, and I'm left with 1. So I have theta equals pi over 180, and that's equal, theta times pi 180 is equal to 1. So I have to multiply both sides by 180 over pi. And that cancels, so I get that theta is equal to 1 times 180 over pi. I put that in my calculator, and what this rounds to is 58 or 57. It's going to be 57.3 degrees. Okay. Okay, so here's the picture. And you might ask why I'm doing this. So here's the picture. I remember the circumference is 2 pi times the length of the radius. So that means each circle has 2 pi radii. That's equal to 1 full circle. So there's exactly 2 pi radii, that's the plural, in a circle. So what that means there's about 2 pi is, remember, about 6.28. So this would be about the length of one radius would be somewhere like that. So if my S is R, this angle here would be about 57.3. That's what we just showed. Okay. Now, I'm going to draw that same picture, except my angle is now going to be in radians. So this same angle is 1 radian. So 1 radian is equal to about 57.3 degrees. And what we saw that 57.3 was 180 over pi. So that's our definition of a radian. Okay. Now, it's a weird definition, and you're saying, well, why do we have to use that? Well, I'm going to give you a bad reason and hopefully a good reason. Why? Just because. That's the bad reason. It's throughout math and physics, engineering. So anything that's scientific that has to do with angles, you're going to be using radians. Now, the good news is you don't use radians in business calculus if you're in business calculus. That's one reason. Calculus formulas are simpler. And I'm going to give you an example that won't make any sense. So, for example, we have this thing called the derivative in calculus. And if I take the derivative of the sine, it's equal to something called the cosine. You're going to learn pretty soon about sines and cosine. That's formula true if we measure theta in radians. If instead we use degrees, we have this factor that comes along. So this formula is easier. So I think that's really the main reason. And we're also going to see that if we saw before that with degrees, this is one we're going to see, and I'll go through it in a second. Our arc length is equal to our angle, pi times 180 times r. And then if we use radians, S is just going to be equal to the angle in radians times the radius. Okay, so to me, this is the main reason we use it. Okay, so I'm going to do some examples in a second, and I want to show you why that arc length is in radians. Okay, now it turns out, well, no, I'm going to do that later. I'm just going to leave that for now. Okay, so in other words, we're just going to leave it that that's what the radian thing is. Now I want to do the formula and that'll be the last thing for converting degrees to radians and vice versa. And radians to degrees. Okay. It's basically the same formula. Here's the picture. There's my angle, theta, and then here's the same picture. Sorry, that just should be the radius. Same angle, and this is going to be theta degrees. This is going to be theta radians. my question. Is the proportion of the circle the same no matter whatever I call the angles? Yes, it's going to be the same fraction of the circle no matter what I call the angle. Just like you have the same height whether I use radians or degrees. So here's what I'm going to say, that theta over 360, because remember 360 degrees in a circle, remember it's 360 degrees, is equal to 2 pi radians. So a circle has 360 degrees or 2 pi radians. Okay. So this is going to be the fraction of the circle of the angle. And that's going to be the same as if I measure radians, as long as instead of 360 degrees, I use 2 pi, which is what the size of a circle is. So that's going to be the same. So that's going to be really simple. So I'm going to recopy that. Theta degrees over 360 is going to be the same as theta radians over 2 pi. So I'm going to solve first for theta degrees. So I get theta degrees over 360 equal theta radians over 2 pi. I need to solve for this, so I multiply both sides times 360. That cancels. That's going to be times 180. So I'm going to get theta degrees equals theta radians 180 over pi. Okay. Now I'm going to solve for, I'm going to call this star because it's really important. I'm going to solve star for theta radians, so it's the same idea. Start with the proportion. I want to solve for that, so I have to multiply both sides by 2 pi. That cancels. That's going to be now over 180, so I get pi over 180 theta degrees equals theta in radians. So let me write that on the next page. Theta degrees equals theta radians 180 times pi. Likewise, theta radians equals theta degrees pi times 180. I want to write the arc length formula. Arc length in degrees. We saw that that was equal to theta pi over 180 times r. Notice what this is equal. That's equal to theta in radians. So I get my arc length in radians, or using radians, is going to be the angle measured in radians times the radius. So arc length, again, that's easier. It's a simpler formula in radians. So that's why people like radians. Okay, so that's it. So I'll do some practice problems in a minute. So thank you. I'm sorry, I didn't mean to cover everything up. That was kind of rude. I was just closing up. So let me take this off so you can see the sort of the summary of what we did right there.